Okay, so here we are going over the Unit 3 study guide. I'm starting with objective 3.4, identify the critical points in extrema and other key values from a function's graph or equation. Here, it asks you in the graph below, what are the x and y intercepts? That's simply where it crosses the x-axis and where it crosses the y-axis. If it crosses in many different places, then you'll have many different x-intercepts, although you can only possibly have one at most y-intercept. Let's undo all this. So the x-intercept is at x equals 1. So we say its full coordinate, which is 1, 0. Please don't forget to say the full coordinate of where it is located. And for the y-intercept, that's this point right here, where it crosses the y-axis at negative 1, 0. Or at 0, negative 1. And remember, when it's the y-intercept, the x is 0, and when it's the x-intercept, the y is 0. Find the x-intercepts of this one and the y-intercepts. Here we have 1, 2, 3 spots where it crosses the x-axis. So the x-intercepts are at, and the y value will always be 0. This is the origin, so back 2. So the coordinate of this is negative 2, 0. The other one is 1, 0. And this one is 2, 0. And then I use my brackets to indicate this is a set of multiple different x-intercepts. The set that includes these 3 points. Close the set. All right, and for the y-intercept, I'll do that in yellow. It can only be 1. And it's right here where we cross the y-axis. And that's at y equals negative 2, so I'll put it as 0, negative 2, because the x-coordinate is 0. Find the x and y intercepts algebraically. So when we're doing the y-intercept, that's the easy one. All we do is plug in 0 for x, because we're looking for when x is 0 when we find the y-intercept. So for the y-intercept, you can't really see that. Let's try it again. You have f of 0 equals 0 squared minus 36. 0 squared is 0, so this is 0 minus 36, or negative 36. And when you're doing the y-intercept, you always set the x to 0, and then the y is negative 36. For the x-intercept, and I'll erase this, all you do is plug in 0 for f of x rather than for x. So this entire thing is going to be 0. The y value, in other words, 0 equals x squared minus 36. If I wanted to factor this, I certainly could, but I can also solve it by adding 36 on both sides. 36 equals x squared. Well, to undo squaring something, I take the square root of both of them, and my final result is x equals plus or minus the square root of 36, which would be 6. So x is plus or minus 6. Now, how do we actually write our x-intercepts? Well, I'll write it as x is either positive 6, 0, or negative 6, 0. And those are our 2 x-intercepts. That's where the function is equal to 0. The whole value is equal to 0. So you're just setting the whole thing equal to 0 for the x-intercept. You set this whole thing, f of x, equal to 0. So this equals 0. And for the y-intercept, you just put x equals 0 and see what you get out as a result. For number 4, it is g of x equals 3x squared plus 10x minus 8. In order to do this, you will just be solving a quadratic equation. So this equation is quadratic because its highest power is a power of 2, and it's all a polynomial. So we know the quadratic formula, which is, and you should write this in your notes, x equals negative b plus or minus square root b squared minus 4ac all over 2a. This is a, the 3 is a, 10 is b, and c is negative 8. So to solve when this equals 0, which is solving for, think about which intercept this is, I'm making the y value, that is g of x, equal to 0. So this is the x-intercept. So the x-intercept is 0 equals 3 times 0. Whoops, that's not right. 3 times 0 equals 3x squared plus 10x minus 8. And this is exactly the kind of equation that this is designed to solve. So to solve it, we just plug in those values for the variables, a, b, and c. So this is negative 10, because b is 10, plus or minus square root of 10 squared is 100. I get that from b squared, because that's 10 squared, 100, minus 4 times a, which is 3, times c, which is negative 8. Negative times negative is going to end up giving me positive. And that's all over 2 times 3, because it's 2a. Simplifying this down is negative 10 plus or minus the square root of 196 over 6. This is negative 10 plus or minus 14 over 6.
Attention students, I need Alencia King to the main foyer.
I'm not re-recording for this.
Jaden Smith to the main foyer. Alencia King and Jaden Smith to the foyer.
Is equal to negative 4 over 6 if you take the minus, minus value. Excuse me, positive 4 over 6 if you take the plus value, because negative 10 plus 14 is 4, and then you divide it by 6. Or it could also be, if you take the minus, it'd be negative 24 over 6. So the results are the y-intercept, or the x-intercept, is negative one of two things. Either negative 24 over 6, well, 24 divided by 6 is 4, so this will be negative 4, comma 0. Actually, 0, comma negative 4, because it's in, no, negative 4, comma 0, because the y will be 0. Negative 4, comma 0. And 4 over 6, we can simplify that by dividing the top and bottom by 2. Divide top and bottom by 2, and you'll get 2/3. So 2/3, comma 0. And those are our x-intercepts. For the y-intercepts, you're just plugging in the value 0 for x. So I will erase that here. Plug in the value 0 for x. This is much, much easier. G of 0 is 3 times 0 squared plus 10 times 0 minus 8. This is 0. This is 0. All we're left with is negative 8. So the y-intercept is negative 8, but with a 0 tacked on at the beginning, because the x-coordinate is always going to be 0. 2 x-intercepts and a y-intercept at the origin. You can verify that it has both of those properties. It has 2 x-intercepts, 1 and 2, and has a y-intercept at the origin. If I wanted to draw one with 3 x-intercepts and a y-intercept at the origin, it would look like this. If I wanted something with a y-intercept at 6, at y equals 6, and 3 x-intercepts, this is what it would look like. 3 x-intercepts and a y-intercept at y equals 6. Give the coordinates and classify the extrema of the graph below. Wherever it hits a maximum, wherever it hits a minimum.